Hello, I'm going to build a robot arm in a day, and in order to do that I need to avoid engineering as much as possible. This is why I'm going to use acrylic. It's easy to cut, easy to drill, and as long as you can make everything out of rectangles, it's a very wonderful substance. So my entire design basically consists of 4 acrylic rectangles. The movement will be supplied by 4 servos. The shoulder and arm bits are done by Lewin Sol 227 servos. These are pretty cheap, pretty powerful, and easy to operate. They just use standard radio control pulse width modulation. The normal kind of servo for a robot arm is the AX12, which is very wonderful but involves getting into serial communication rather than just PWM. The other good thing about the Lewin Sols is that they come with all the bits, with all the brackets and screws and nuts and bolts you can need. So you can just attach them to bits of acrylic, and one at the bottom, one at the top, and away you go. You have the basics of an arm. The claw is normally done by metal with gears and complex linkages, which are very difficult to make yourself, and also very liable to jam if you actually buy one. So I'm just going to use 2 small servos, MG90 micro servos. These are very reliable and surprisingly strong for their size. You put it all together and you have a robot arm. One thing that's worth mentioning is that because the MG90s are rather a long way away from everything, they're quite likely to jitter. So it's worth putting a capacitor or 2 as close to the ends as you can in order to cut down on that. I've also made some little circuit boards because I don't like having wires connecting in the middle of empty space. And I'm actually running the servos using a Pololu Maestro controller. These are very nice little devices, and they get you over the problem that the Raspberry Pi only actually has one GPIO pin that will do hardware pulse width modulation. The biggest Maestro will run 24 servos. This is only a little one, it'll run 6. So we put the whole thing together and wire it up, and you have a robot arm. Let's see it in action. Now this arm can only move in one plane. It's a 2-dimensional arm. So to make it more useful, we can add rotation and other facilities to it. But basically, that's it. For the purposes of the Connect 4 project, we have an arm that can do the job of lifting the counters. So we'll leave the addition of rotating base to another video.